Greetings to all. Today we will understand multiplexer based latches and how to program it. We are going to program it by cutting the feedback loop present in the multiplexer. So before that, if you take any sequential circuits, it will contain both combinational logic, which is going to take the circuit to the next state, and the previous values which has been given to the system is going to be remembered by the memory element. So the memory element can be static or dynamic. So when you take static memories preserve the state as long as the power is turned on. So mandatory is power. And static memories are built with positive feedback or regenerative feedback, where the circuit topology consists of intentional connection between output and input of a combinational circuit. So we will understand this. We take this as NOR gate. So this connection between output and input is nothing but the feedback connection, which is going to be positive. So this is valid only when the power is on. So the memory element is going to store the value as long as power is applied to the circuit, and it is going to retain the memory. When you take dynamic memory, the memory stores the state of short period of time on the orders of milliseconds, and they are based on the principle of temporary charge storage on the parasitic capacitor associated with the MOS device. So if you consider a MOSFET, so there will be a capacitance between gate and source, there will be a capacitance between gate and drain, there will be a capacitance between substrate. So all the terminals or all the node of a MOSFET will have some associated capacitance, and these capacitance are being used to store the charge, and we are going to retain the charge or refresh the charge with clock signal, and that is how the dynamic memories have been working. So next is, we will go to multiplexer. This multiplexer contains two input and one output. So we are going to consider this multiplexer as a negative latch. For a negative latch, when clock is low, the input 0 of the multiplexer is selected, and D input is passed to the output. When clock signal is high, the input 1 of the multiplexer is selected, which connects to output of the latch, and the feedback between output and input is going to be retained. So we will understand before getting into it. We will understand that clock is equal to 0, and we make D is equal to 1. So when clock is equal to 0, this D which is connected to the 0 input is being selected, and we are going to propagate D to the output. So Q is equal to D into clock bar. When clock is equal to 0, D is being selected. When the other case, when clock is equal to 1, this D input is being selected, and D input is being connected to the Q output. There is a feedback between output and input, and this is going to retain your value at the output, which is Q into clock. And this is the governing equation which defines the negative latch. When you take positive latch, this is going to be your positive latch. Q is output. When clock is equal to 1, D will be selected, plus when clock is equal to 0, when clock bar, it is clock bar, it is going to retain whatever is been stored in the previous time. So it is going to be Q into clock bar. This is the governing equation for positive latch. So similarly, in positive latch, D input is selected when clock is high, and output is held using feedback. So this is the way we program this. We can construct multiplexer using transmission gates. So transistor level implementation of positive latch based multiplexer is shown. When clock is high, and clock bar is 0. The bottom transition gate is on. So the clock bar is 0. The PMOS, this PMOS is on state, and NMOS gate is being connected to 1. So NMOS is on state. We consider this as transition gate T1. We name that as T1, and this is T2. So when clock is high, T1 is on condition, D is copied to Q. Similarly, when clock is equal to 0, we change this to 0. So this clock bar will become equal to 1, and this 1 will become to 0. So what will happen to T1? The PMOS is being connected, gate is being connected to 1, so it will be in off condition, and NMOS gate is being connected to 0, it is in off condition. So T1 is totally off, and T2 is. What about T2? The PMOS is being connected to 0, gate is being connected to 0, and the NMOS of T2 is connected to NMOS gate of T2 is being connected to logic 1, so T2 is on. The Q retains previous value. So this is how it has been programmed, and this is nothing but D is being copied to Q only when clock is equal to 1. So it is positive latch. We can build multiplexer based master slave configuration. This is nothing but master, and this is nothing but slave. Most common approach for considering edge triggered register is to use master slave configuration. The register consists of cascading of negative latch with a positive latch. So when clock is 0, D is being connected to QM, so it's a negative latch. The second latch which is called a slave latch. The first latch is called master, and this is called slave latch. When clock is equal to 1, this QM is being copied to Q. So this is called as positive latch. So when you cascade two latches, one is negative and which is also positive, when clock is equal to 1, my Q is going to be available. So it is nothing but positive edge triggered register. So this is how things being constructed in the case of digital integrated circuits, and thank you all. Thank you.